Well, hello everyone, welcome back to Adrian's Digital Basement 2. On today's video, we're going to be taking a look at this Magnavox Smart Series 13-inch color television. Yeah, it's pretty boring, and I've actually had this exact model on the channel before, although it wasn't for a repair video. I used the guts of one of these, well, the CRT from one of these, to transplant into a 1702 monitor along with the multi-standard, multi-format Chinese CRT driver board to upgrade my 1702 to have a tuner and PAL, CCAM, NTSC support, all of which it doesn't normally have. This particular TV, though, does not work. It appears to be physically in good shape. I mean, there's a little scratch here and there on the front bezel. CRT itself has a scratch on it. Yep, there's one right there. And I made a video on the second channel, I think it was, where I tried to polish out the scratch on a CRT using polisher and some compound that kind of scratched away the glass, and it did a decent job. Unfortunately, these TVs are especially prone to scratching because you can see how bulbous it is, and the glass, the front of the glass, is what sticks out the most. So if you put this thing face down on anything other than, say, a towel, it will obviously get scratched very easily. And someone could have just put this down on the ground temporarily because this TV is broken, and then that's what scratched the glass. So this particular TV doesn't work, and that's one of the reasons why I want to take a look at it today. I want to see if I can maybe get this thing working. But I happen to know that even if it doesn't work, it's not the end of the world, because I know that the CRT itself is usable, especially if I polish that scratch out, then I can transplant this into another monitor to save it and make it work. Now, one of the things that's really interesting about this television, besides the fact that it's like completely boring commodity television, is that for some reason on the side, someone has gone ahead and installed two, well, they look like 1/4-inch audio jacks. Why? I don't know. The television already has a headphone jack on the front, along with the video and audio input. That is the only video input. The back of the TV, if we rotate this around, it just has a single RF jack. You can't really see it there, but yeah, it's got an RF jack there. It says here, made in China. It's made by Philips Consumer Electronics, North America. That's why it's sold under the Magnavox brand name, and it says manufactured in May of 2003. Now, the funny thing is about this TV, as I said, it doesn't work, and that's really unusual because these are incredibly reliable. These late model picture tubes have the tinted glass, so the phosphor is a little darker than you would find on older sets, but they're also very, very long-lived. And that makes these excellent candidates if you have something like, say, a Commodore 1702, and you want to transfer the CRT over into that chassis. But what I really want to look at is what's going on with these two jacks, because that's unusual to me. And when I first saw this, I kind of immediately thought that maybe there was some circuit bending going on with this set, and maybe this has something to do with why it's not working. Now let's plug this into the power supply here, and I just want to demonstrate what it's doing when you try to turn it on. So I'll just get that plugged in there. If I turn this on, okay, so let me move the microphone closer to this. So that sound is absolutely indicative of a switch mode power supply attempting to start and then going into a protection mode. So most likely this set probably would have just tried to turn on its own, because usually the microcontroller that's on here has a little bit of NVRAM and it stores the last state of the TV. So if this thing was on when it was, well, say unplugged, then now plugging it in, it just tries to start back up. But every time it's starting back up, there must be a short, I'm assuming, and that short is keeping the set from working. And it seems that the microcontroller in here, because you heard it just trying over and over again, obviously once it fails to start, it just keeps trying to start over and over and over again. So first things first, it's just Phillips screws. There's two on the top, probably some on the back. I want to see what's going on with these unusual jacks here. Why did someone do this particular mod? What makes me laugh about this set is like the plastic case is so thin and flimsy feeling, and yet two screws on the top, two screws on the sides, three along the bottom, and another screw right here. There are a lot of fasteners holding this case together. I guess when you're relying on the front plastic, the back plastic, and all this to be held together tightly to give this set any kind of structural rigidity, you got to use more fasteners. You probably save the money on the cheap, flimsy case instead. All right, all the screws are out though. Let's get this off. Now, the problem is, whatever these are, if they're connected with wires, they're going to be permanently connected, and hopefully there's enough length so that I can easily pull this up. Whoa. Um, um, okay, you won't believe what's going on in here. I'm shocked. I am totally shocked here. Can you tell what those jacks are connected to? Yeah, they go to the deflection yoke directly. So this was without a doubt used for some kind of circuit bending. My assumption is, well, the set, wow, the wires, yeah, they're just cut down here on the main board. My assumption here is that someone thought they could connect the deflection yoke directly to probably an audio source, like an audio amplifier, and try to turn this thing into an oscilloscope. But that doesn't work because the deflection yoke right here on the CRT, this part of it, is a critical component of the entire high voltage horizontal deflection circuit. Without this being connected, you're not really going to get high voltage. You're really not going to get a working television. So this really feels like this was someone's experiment here to, well, do something interesting. And without a doubt, these are 1/4 inch jacks, like an electric guitar or something. And I think it must have just failed spectacularly. I don't know, but I mean, yeah, down here, these are the little offcuts from the original connections to the main board. And what's wild, what's absolutely wild inside is this television. Let's zoom out a little bit. This TV looks brand freaking new inside. Like there isn't even any, I mean, there's not even any dust on anything. This thing doesn't even look used. Unbelievable. All right, so obviously I'm gonna have to undo what they've done here, because if we're gonna see if this thing even works, I need to reconnect the deflection yoke. So we're just gonna take these nuts off and the washer so I can get these jacks out of here. Back cover looks absolutely perfect with no issues whatsoever, not even any real dirt or dust in there. And yeah, I mean, this does not work. You cannot do this. This is not going to result in a working television, not even remotely working television. Now, I suppose it's technically possible. I don't really know, much about the way this driver board works, that it would have tried to run the set, like run the horizontal deflection without the coil there, without the deflection yoke that is plugged in. It's possible. And the fault that we're having here is unrelated. But we could also just be simply having a protection circuit that just shuts down the TV as soon as it detects that the voltages aren't correct and they're running out of spec, just as a protection thing. So it's quite possible that whoever added these jacks, well, when they did it, the TV just never worked. And instead of them putting it back to the way it was originally, they're just like, I'm just, going to recycle this TV. Now, I didn't mention this, of course, but it goes without saying that you should not, absolutely should not open up and work inside a CRT unless you know how to do so safely. On a color television like this, there's potentially 25,000 volts being generated and going to the anode cavity. So inside the CRT glass, the outside here is ground. I'd say there's pretty much a 0% chance that there's any high voltage stored in here at this point, because there's just no way the TV was working, especially as you just saw what was happening. But just in case, I'm going to take my high voltage probe here. This goes up to 36 kilovolts. I'm going to connect it to the ground of the CRT that's touching this gray matte surface here. I'm going to stick this inside here. And nope, absolutely nothing. It would have registered on the meter here, and we had nothing. And if there were any high voltage stored, just the load of this meter would drain that all the way down to 0. I am going to remove this rear neck board off the back. Just don't want to potentially damage the CRT because of all things. Yeah, it's a Chunghwa CRT, but like I said, these are extremely reliable CRTs, very long-lived, very, very good to swap into other sets that are worn out. And because this is not a Philips CRT, it's generally very compatible with other types of displays. It's just TV grade, so it's very bright. It's got a high dot pitch, and that makes it low resolution. What we really need to do here is we need to restore these connections back to the original connectors. And how nice of them for leaving these original connectors on here. So we have this one, and there is this small connector here. This is the other one. Luckily the wires are color-coded, no issues. So I'm just gonna take a moment to reconnect these, and then we'll give this thing a test and see if it works. Connectors have been reattached. Luckily one's 3-pin, one's 2-pin, so there's no issues reconnecting these back to the main board. Plus they have little clips on them, which means you can't plug them in backwards. If you plug them in backwards, you will get like a picture that's flipped over, as long as you don't plug them into the wrong thing. The horizontal has to go to the horizontal, vertical to vertical. Okay, obviously before powering this up, I can't even really test it with this disconnected. I mean, you can, but highly unrecommended, highly not recommended. Okay, that's reconnected. You can run it with the CRT disconnected, although it might detect that and shut down because there's like a beam current sense thing on a lot of these more modern sets. I'm just noticing on this little neck board here, it actually has two different footprints because almost certainly this board probably is used on like the 20-inch or 19-inch version of this set. And typically those CRTs use a larger connector. So this smaller pinned one here is for the low resolution TV grades, 13-inch CRTs. And there's a larger one with more pins, even though it's the same exact signaling. That is for the 19-inch version. So I bet you the control board on this thing really is designed for both of those sets. There we go. Okay, everything is back in. Before powering this up, and if this thing actually works now, you got to make sure the ground lead from the CRT is connected to the neck board, and it is indeed right here. This actually can be disconnected. So that is connected, that's good. I'll just give this a quick visual inspection just to see if anything looks burned or damaged or leaky caps. That could have been why this thing wasn't starting as well. Although this set, by the way, it does use an isolated switch mode power supply design. So there's the switch mode power supply in this section of the board. On the bottom of the PCB are a bunch of surface mount components, little controller chips and things like that. But there are a bunch of diodes and things on the top side. And at least obviously on first impression, just looking down at it, everything looks fine. Okay, let's get this thing plugged in to my power strip here. Let's move this out of the way so it's not blocking your view of the CRT. And here we go. I'm going to turn this on. 3, 2, 1. Nope. Still not working. So it's making that same clicky noises. And it is not starting up. So you know what's funny is I went into my scrap board and I found another board that's for this television. Now, I've already pillaged a bunch of parts off of here. The tuner is missing. Some of these larger caps are missing. I think I used them on something else. This came out of the same set. Now, weirdly enough, the board actually looks different. The one that's on the TV has like a big hole here where the neck board came from. And in fact, this one does also have two connector or spaces for two different connectors. I'm positive that this came from a TV that looked just like this. In fact, the front buttons here, kind of the same thing. This one's a little bit bent, but same silver plastic. So theoretically, this would work in here, but like I said, I've already stolen a bunch of parts off of this, so this will not work. I knew I had this, so I kind of assumed that I would have backup parts if this thing needed to have, stuff repaired on it, and I could just pull it off this board. But on first appearance, unfortunately, this board looks so different than this that I don't think a lot of the parts are interchangeable. In fact, I just noticed on my scrap board has a large Philips IC controller thing. There's nothing on this. It's obviously a surface mount on the bottom side. All right, so let me get this thing out and we're gonna start looking for faults. Okay, here are the two boards. You'll notice this one, this is the scrap one, is completely different. We have the large IC. This thing doesn't have that because they're on the backside surface mount. This cutout, if you wonder what that's for, that's because they made the neck board as part of this and then they just snapped it out just as a way to save cost. This one, on the other hand, I'm assuming this was separate. It doesn't look like this has anywhere where it was broken off. But you can see from the front controls and the jacks and stuff, obviously these are from the same television set. Looks like this one, and this one, had capability of having stereo audio. There's some missing components and whatnot. This is very typical for Philips to support multiple features and sets, all with same board. Just like with the Commodore 1084, the Philips version, all sorts of parts on the boards can be moved around and optionally added to add stereo sound, not stereo sound, SCART, no SCART, all sorts of stuff like that. And that's no different with their televisions here. I just wanted to see if the flyback is the same. So JF0501-19105. And this one is JF0501-19304. This one looks like it has a 2005 date code on it. And this one has a 2003 date code. So this one with the surface mount stuff on the bottom is older than this. But the thing about this set, which I didn't like, is that it's an all-in-one solution. This is the scrap board, right, that came out of another set. There's no way to RGB mod this because the microcontroller, the jungle IC, everything is all in this one thing. There's no external RGB inputs to this. Well, it does have RGB inputs, but it doesn't have a separate OSD chip that generates RGB signals, then goes to the jungle, which you can tap into to add RGB. The problem with this chip is while it has RGB inputs, if you look up the datasheet for it, you have to have firmware that enables it. So everything is a firmware thing. I'm pretty sure this is the I2C firmware chip there. So maybe not even this set, but this chip used in other sets and other markets supported RGB based on firmware that would set some I2C bits, and then it would enable the RGB input. In addition, this supports PAL frequencies, but this particular one is missing the ability to have the delay line and what else is needed for the PAL color decoding. So this set, I remember if you feed PAL into it, this particular one, and you get black and white, but it does have a good image, it's just black and white. And this chip, the part number on this just has no support for any kind of PAL color decoding. Now the one that's not working, if we look at the back side, let's see what we see here. Okay, so this has a 2-chip solution, which almost certainly means that there is an RGB signal going between these. One will be the jungle IC and one's going to be the microcontroller. So this is like the code that's running the entire set. And generally when you have a TV like that, the on-screen displays are generated in the microcontroller and then sent to an RGB input with a fast blanking signal to the jungle chip. I don't know which is which. And then that enables on screen. And that's what you would tap into if you want to do an RGB injection. So it's actually possible with this set, which is actually kind of cool. Now, when it comes to troubleshooting, I don't have schematics, and maybe there is schematics for this, so we might need to look for it. But the first thing I want to focus on is the high voltage power supply, which is self-contained in this part of the set. So this part of the set, if this is actually plugged into the wall, is dangerous. I mean, of course, there's voltages being generated for the B plus and stuff too, but this is not isolated from the mains in your house, the wall. So touching this while it's running could be lethal. So you have to be very careful with that, unless you're using an isolation transformer. Once this stuff does its switching, this is the switching transformer here. So everything on this side of the set is actually isolated. So if you hook the video inputs into this, the ground is not referenced to anything in your house mains. It's completely isolated because of the transformer and the galvanic isolation that provides. These little holes in the board and the lack of solder resist is all part of just creating an additional isolation layer between this high voltage side and the rest of the set. Now the first thing we need to do is, it sounds like the power supply is not starting properly. Now this cap, there's a large cap right here, this one, this is going to be the mains reservoir cap. Basically AC comes in, it's turned into DC, high voltage DC, so there's a rectifier, a bunch of diodes, then that turns into, 200, 300 volts, whatever it is here in North America, and then that gets chopped by a switching transistor, and if we look here, this will be the switching transistor because it's right there with it. It's on this high side or on the hot side. And then that gets sent over to this side, and on the output of the transformer, there's going to be some caps over here that turn it into various rails that are used for the set. There's going to be like a standby rail. There's going to be a B plus rail. It's going to be like 160 volts probably. Let's take a look. And yep, you see these caps right here. These are going to be the ones that are going to be taking those various voltages from the switch mode power supply, and then that gets distributed to the rest of the set. You'll have an optocoupler, which is this device right here, and that is going to be connecting this side. This is the secondary side or the low side back to the controller that's on the high side. Then what this does is, there's a resistor divider thing, and this will allow that signal to get back to this side, but it still be isolated, so there's no connection between the high side, the dangerous side here, and the low side, and that allows it to adjust and regulate that voltage to keep it within spec. Now, when it comes to this power supply not starting, this is just like any other switch mode power supply, we could have an issue, say, with a small little cap like this that is allowing, this is like the bootstrap cap almost certainly, this is what allows the switching power supply to even start when you first connect it up to the mains. And it could be that this is bad, so it's trying to start and it just doesn't have enough reservoir or capacity in here to actually stay running. And a lot of times, because this might be near a hot resistor like this, that it can get kind of baked and not have enough capacitance. But another common reason for the power supply kind of starting and making that clicking noise is we have a short somewhere on the output. So there's a few things that we need to do. First thing, I should probably start inspecting, looking for broken solder joints and or cracks. This kind of PCB material is very easy to get cracked, and then that creates breaks and traces and things don't run. But this is definitely where we have to kind of focus our attention first. So I think the first thing I'm going to do is I'll look for some cracks. If I don't see anything, I'm going to check this in circuit just to see if this has, you know, whatever it says on the side. I can't quite read it here, but I'll look to see if that has whatever it needs. This is going to be fine. You don't need to really ever check these. And then what I'm going to do is start checking across these caps and looking for shorts specifically. If we kind of look at these caps, like this one here is 160 volts. Let's see what else we see. 16 volts on that one. This one I have my finger on is also 160 volts. So these two are relatively high voltage, B plus probably. That's, you know, obviously like a 12 volt rail, something like that. And that small cap there is 16 volts. Okay, so relatively low voltage. And, you know, all of these things are probably going to be parallel. These other caps over here will be paralleled onto these rails. But judging by the diodes on the output side here, this has at least 2 rails on it, might have more. So that's a large diode, and that's a large diode, and there's a diode. So I don't know, I don't have the schematics here, but this should be enough for us to start like poking around and looking to see if anything looks obviously wrong on the board here. Incidentally, if we plug this in and we had a shorted fuse, which we don't, fuse is right here, we know that it's a good fuse. You got to always suspect that you have a short on the primary side here, this high side. So this is the bridge rectifier, for instance. If one of those goes short, that typically will just blow that out immediately. This, incidentally, with a little bit of burn mark on the board, is for the degaussing coil. What's it, varistor? Thermistor? I can never remember what those are called. It essentially starts out with a very low resistance. So when you first plug in this set, even when it's off, what typically happens is the degaussing coil, which is connected here, will get 120 volts. You'll hear the hum for a split second. This heats up, and then that goes high resistant. So the degaussing coil, instead of being just directly connected to 120 volts, it is now going through this resistor in series, and that becomes so high resistance that essentially the degaussing coil doesn't have enough voltage to even do anything anymore. But this thing stays hot all the time, which eventually can fail. When they fail open, so then your degaussing just stops working altogether. I'm just going to look for anything that looks out of the ordinary, cracked solder joints or blown up components, because you see there are like a whole bunch of components on the bottom side here, surface mount things. Not so much in the power supply section, although there are a few things here, mainly in the rest of the set. Going to look for anything that looks broken, cracked, burned, things like that, and cracks in the PCB. And since I don't really know if this set was like thrown around a bunch before I got it, then that's always a risk. So I find for cracks and broken solder joints, to be honest, sometimes what you can do is use a flashlight off to the side. One other thing I want to mention, I don't see any cracks or anything. One thing I want to mention is that sets like this typically run the switch mode power supply all the time. This was before like Energy Star and all that stuff, where the microcontroller has the ability to shut off the power supply entirely. I'm pretty sure the power supply just runs constantly, is always making 160 volts and whatever the other voltage rails are. And the microcontroller shuts down all of the TV side of things, but the power supply is always running. Not to mention the degaussing coil is also connected up. It just means this set's not really that efficient in that it like uses up standby power, probably a couple watts to have this running all the time. Incidentally, also, when I had this plugged into power, I did try pushing the power button. It didn't do anything. It didn't stop clicking, and it didn't try to turn on or do anything different at all. I did push all the buttons on the front because I wanted to see if that just had any effect, and it didn't. All right, let's start with this little reservoir cap here. This is 47 microfarads, and it is 25 volts. So let's just see what this measures as. Picofarads? Nanofarads? Is that in focus? It says 2.9 PF. That's not correct. Just so you can see that this meter is actually working, let's grab another cap here. There's just something random that was on my desk. 330 microfarads. And there it is. We're at 310, 303, and this is running at 1 kilohertz right now. Now that particular cap would be exposed, if we go to frequency, to something like 100 hertz, or 120 actually here in North America. So there, I'll set it for 120 hertz, and we will measure that again. And again, 16 picofarad. I think that gap is maybe bad. I think it's bad. That's not good either, because that particular cap is a TL brand, whatever that is. And that is obviously used elsewhere on the board. Like that's another one there, and there's more of them. This is a Rubicon, so that's good quality. This is Gicon or Gcon. So this doesn't have the best quality caps. But for instance, this one, which is looking dead, let's measure one of the ones over here that's not exposed to a bunch of heat. And let's see if one of those is okay. And let me just look again what this is. 25 volts, 47. Let me find something similar. I mean, here's a 25 volt, 100 microfarad cap up here. Let's see what that is measuring as. 94 microfarads. So it's not perfect, 1.3 ohms, but it's good enough compared to this piece of junk down here, which again, you know, mega ohm, I don't know. That's just, it's dead. It's totally, totally dead. Here is 47 microfarad, 50 volts. I'm going to say that's close enough. It just really needs to be at least higher voltage, or same or higher voltage. And if we pop that in, there we go. That's normal for a 50 volt cap there, 1.7 ohms, 47. Should be totally fine, to be honest, in that circuit. Sometimes ESR matters, and the higher voltage it is, the higher the ESR is going to be. But I think in a power supply circuit like this, yeah, non-issue. Oh, and you know what? While we wait for the desoldering iron to heat up, let's see what's going on with that cap. So there's the same cap. It's 85 degrees. It's the same crappy TL brand. 50 volts, 22 microfarads in this particular set. Why don't we measure that, see what it is. It's not quite as close to a big resistor. There's a little resistor there that probably gets warm, but it's certainly not going to be nearly as bad as this other set. So it's 5 ohms, 19.6 microfarad. I'm pretty sure this set worked, this one here, before I stole these parts off of it, because I really needed that CRT to put into the 1084. What is this again, voltage-wise? 50 volts. So it's a little high, the ESR on that, to be honest, because remember, I lost it already. Oh, here it is. The new 50 volt cap that we're putting in there was only like 1 point something ohms. So this is these are crap quality caps on these boards. All right, there's our little guy, our culprit. Well, at least one of the culprits for this thing not working. Yeah, 25 volts, 47 microfarads. Now the one I'm putting in here is kind of junk as well, but it's newer junk. So let's remove those offcuts, which incidentally I like to keep. I just have a little thing here, just filled with these. You never know when you need little jumper links or whatever. These little offcuts are perfect for that. Okay, I can't measure that on the top anymore because, well, I put the new cap closer to the board than the original. So let's get this in view. And we'll touch the probes onto the pads. There we are, 47 microfarads, 1.6 ohms. So yeah, it measures pretty much exactly what it was measuring before. All right, so there's a few things we could do for testing. I could just try to power this up as is on the board, like laying on the table right here. Because the deflection yoke's not connected and nothing's hooked up, I would still recommend putting this inside like a glass or something, just in case this thing somehow managed to generate some amount of high voltage. It's possible. But what it would allow us to do is actually measure what's happening on these caps here. I'm sorry, there we go, these caps here. So we can see that if we have like the B+, that 100 and whatever volts, it's not gonna be 160, so it's probably more like 120 volts, which is a typical value for these types of TVs. But I'm not even gonna bother. I mean, obviously one thing we could do is at least look at the board and look for caps near hot things like these, and we should just check those values, I suppose, just in case those have gone bad as well. I'm not gonna bother over here because, like, say there's a power resistor there, but, well, I guess it's worth checking that cap. But like stuff that's far away from, you know, things that get hot, that probably gets hot. This is probably a little audio amplifier, so that might be worth checking. But yeah, when you see stuff like this, or this, or this, and this, anything that's near them, caps-wise, you could just quickly give it a little quick test, just a quick test. Incidentally, by the way, this thing, this is DEREE LCR meter. I've had this thing for a long time, but there are new versions of this, like Finersi has one, I think, untested, that I think is pretty inexpensive. So if you're looking to get one of these, I think that's a good modern solution that's cheaper than this thing was back in the day. Let's switch this thing over to ESR mode because that's what people like to look at. I'm used to looking at the D value, but whatever, doesn't really matter to me. So one thing is, by the way, when you're checking caps, is you don't even necessarily need to look to see what value they are, because we're just looking for things that look dead. Like this one. Is this thing dead? No, not dead. We're making good contact. 42 microfarads, 1 ohm. Fine, totally fine. I don't know what the actual value of that cap is, but I'm sure it's something like that, and that's going to work. It's not picofarads or nanofarads. Let's try this random cap. It's over by audio amplifier. It's like probably a 10 microfarad. I'm at 1 kilohertz there, so it's probably 10 microfarad, 3.3 ohms. Totally fine. It's probably a 50 volt cap. Let's just look. Yep, 50 volt cap, 10 microfarads. So yeah, close enough. That's fine, no issues. This is the cap we've already changed, so don't need to worry about that. We don't need to worry about this big one because those pretty much always are fine. These parts get hot, so let's look at these caps that are close to these 2 heat sinks. And they are close to the board, so I'm gonna have to test them on the other side, but there's a couple there, one there, and these ones as well. So this one here is 4 microfarads, but 6.6 ohms. I think we can not worry about the fact that the resistance looks high, and that's because it's probably like on the 160 volt rail, B+, and that's normal. For high voltage caps, they have a higher ESR. Now, luckily, Philips marked on the board, they have the polarity on there, so I don't need to look at the other side. 4.5 microfarad, fine, totally fine. 40 microfarad, fine. 84 microfarad, 0.6, that's going to be a lower voltage cap, totally fine. Again, I'm just looking for things that are like way out of whack, like ESR, see that's 6.66, something like 60 ohms, or like tiny capacitance, like in the picofarad or nanofarad range. That's where we have to be suspicious that there's a problem. That one is fine. Oh wow, I just messed it up, but there was a big blob on here. So this here, so see this? That was not shorted, but it was like almost shorted. Not good, not good at all. I think that's a lead actually, but it was like very close there. Let's cut that off. Okay, yeah, that's a lot better. In fact, what I kind of recommend, I can't find it here, but we'll use this instead. Sometimes what you might want to do is grab something like a toothbrush and just tilt the board over and do this on the board to get those little balls of solder off of it. Because obviously you saw there that that could cause an issue. And if we tilt the board over, if I dislodge any, they should hopefully fall off. And I can see little bits of them on the table actually, yeah. Okay, so anyways, back to the caps. The one thing I need to check is those. Those are probably going to be fine. It's usually the little guys, the little ones that are near hot things, those are the ones that burn up. And I'm pretty sure this cap is really under a lot of pressure. I think this one just gets abused. It's a very common part to fail on a lot of power supplies. But the little guys that aren't near heat sinks, not so much of an issue. Anyways, we checked these ones, so I just need to look at those ones, these ones right here, these big guys. 924 microfarads. This might be in parallel. Or 2 right here. Nope, not in parallel, but they're both fine. Okay, I think that's the last ones I feel like I want to check. Well, like I said, we could try bench testing this by just turning it on without anything hooked up, see if we have B+, but I think I'm just going to go for broke and put this back in the TV since it's really easy to do that, not hard at all. All right, the TV is mostly reconnected. I did not reconnect the degaussing coil. I didn't hook up the speaker, but the ground lead, which is this black wire here, if we turn this like this black wire, this is connected back to the neck board. High voltage anode is connected. Neck board is reconnected. And oh, deflection yoke is also reconnected. Let's just move this degaussing coil out of the way. But yes, I have the deflection coil reconnected as it should be. I'm just going to push the power cord back into the little wire management thing that's down here. It had a bit of glue on it that I broke off to get the wire out. All right, I'm going to plug this into this power strip, which is currently off. And we'll turn the TV just so you can see it. And here we go, 3, 2, 1. Well, it's still doing it, everyone. It just took a lot longer for it to start having that problem. Interesting. Very interesting. So when I turned it on, it just sort of sat there for a second, and then I started hearing the like tick, tick, tick. Let's turn it back on. None of the buttons do anything at all. Interesting. So problem not fixed, even though absolutely this cap I took out of here was totally dead. Okay, so I'm gonna try to put this into what is known as service mode. And that's where you tilt the board up like so while it's still connected to the set. So I have the neck unplugged, but I'm gonna get this reconnected here. Or sorry, not service mode, the service position. That's what this is called. And sometimes you just have to like cut some zip ties to give a little bit more length to the wires. And sometimes if you want more stability, you just like take a plastic bottle like this and sort of prop it up on that, something that doesn't have any metal on it. The reason why this is useful is because it's good now that I can measure potentially some voltages here that are coming out of the power supply. Again, it's going to be these capacitors here that I want to look at just to see what they're doing when this thing is going into that weird kind of shutdown state. Multimeter, there we go, you can read that. I've turned off the auto ranging. And what I'm going to do is I'm going to power this thing on, and I'm going to probe these caps that are coming off the power supply section here. I want to see what voltages are being generated, if anything, when it's making a click, click, click sound. So here we go, 3, 2, 1. Well, that's like nothing. And I'm pretty sure that large cap that I was just measuring, that was the B+. That was a 160 volt cap, 47 microfarad, and there was nothing happening on there. So I'm going to turn this back on, and I'm going to probe some of the other caps. There's another one right here. There we go. I mean, nothing. Okay, well, what I'm going to do is I'm going to, sorry, that's hard to see. I'm going to measure the high voltage side. So there's a large reservoir cap here. So I have the ground lead clipped onto the negative rail, and I'm going to touch this. I mean, look, that cap is charged right now. Even though the set's unplugged and off, that's kind of why you really have to be careful touching this section of the board. That would give you a wallop. If we turn on the set, oh, there we go. It just stays at that value. So that cap is, is very good. But danger, danger in that area there. You'd get a shock if you touched it. Hence why I'm using a glove with rubber on it to even handle the board right now. So we know the rectification side of this is fine. Now the question is that cap we just changed, on the other hand. Let's move over to that. Remember I put a 50 volt cap, let's turn this back on. Yeah, I mean, it's charged up. So the high side of the power supply does seem to be working, but then the secondary side doesn't seem to be making any voltages. And we have to ask the question is like, what's happening exactly? Is there a short, or is something wrong with this transformer, for instance, on the switch mode power supply? Now there's a couple things I could try doing here. I could try just using a bench power supply and like feeding power directly into the low voltage side here and just running this directly without this whole power supply at all. Problem is I don't really know what the B+ is supposed to be, and I don't even have a power supply that can generate enough current and 120 volts, for instance, DC. I could definitely power up the low voltage side, which would power up these chips. And without B+, of course, well, you know, it's not going to be able to run the television, but it should be able to boot up the set at least, where it like tries to work. One thing I'm going to do is I want to put this thing down is I'm going to use this resistor to try to discharge the large cap here. There, I just sort of hooked it on to discharge that reservoir cap. So now if I measure that large cap, you're at less than a volt. We are not at risk of getting a shock. Now, one thing that's interesting is I was looking to see if this is using a controller to run the switch mode power supply. That would be something over here on this side. I don't see anything. There was nothing on the back side of the board. Something is going to be driving this chopper transistor, unless it's integrated. How many pins does that have? Like this scrap board, that only has 3 pins. This is definitely the chopper. This is what's driving the transformer with the high voltage. But usually you have like a controller IC of some kind. Oh, there it is. Okay, so this is a scrap board. That's the chip. That's the controller IC for the whole switch mode power supply. Those can fail and cause the whole power supply not to work. But I don't see anything like that on this board. Because if we look at the bottom side here and we look at the high side, this is the whole high side. Notice there's no surface mount ICs on there. There's not even a footprint for one. So it's not like someone stole a part off of here. Oh, you know what, although? This here, this is the chopper. it looks like it's got 5 pins. So I bet you it's integrated into this component here. Yeah, this is it right here. So it's those 2 pins plus these 3 pins. So it's got 5 total pins. Without a doubt, the controller is built into that chopper. It's not like you can't get these. I'm sure it's just a normal part, but if that has somehow failed, it keeps the power supply from working. That could be our issue right there. Okay, but you know what I'm going to do still is let's check these diodes out. That's fine. Normal diode drop. Normal diode drop there. Normal diode drop looks good. There's a couple small guys over here, just little things. That's normal. Looking for anything that's like open or shorted or not between like 0.4 and 0.7. 0.6, totally fine. Check that one already. How about this guy? Oh, that's a little weird. Oh, that's a bit weird, 2 volts, but you know what? It's probably in parallel to a resistor. Oh no, the other way around is 0.6, so that's fine. That's that little one. Optocoupler, 2.5 on one side, which is fine. And 0.8 on the other side. This is on the low side, so that's fine. And now I'm on the high side, by the way. I know you can't really see what I'm doing here, but just basically touching all the diodes and looking for anything that looks out of the ordinary. It's good. It's good. I don't need to check the rectifier because I know that's fine. That one is fine. I mean, I don't see any problems here. I really don't. Check those. I mean, now we're getting far away, or I don't think it's likely that anything further away is going to cause an issue. And again, unless there's something loading down the circuit, but it would be funny for that to be happening without me being able to even see like a dead short on this when I'm checking across the output or these filter caps on the low side, the secondary side of the power supply. I think what I might need to do is I'm going to switch this into multimeter mode because that's going to give us a better view if it's like trying to pulse up and then immediately failing and coming back down. And I'm going to use this probe. This is a 100x probe. So I wrote 100 on there just so I can tell. 100 to 1, 120 megahertz. So this is good for using with a scope like this because you don't want to just be putting like 100 volts into the input side of this. When you have a 100x probe, it turns 100 volts into 1 volt. So it's much easier on the input side of the scope. You do have to go in the menu though, and the later firmware actually has a 100x mode. There it is. So now we're in the correct mode. Just make sure I'm on the correct channel. Yes, channel 1. There we go. So I have it in normal trigger mode. So every time it tries to start, it does go up, and then the voltage is clamped, and it's like it gives up. So we get this pulse, and I don't know how high that's going. We're at 2 volts per division. It's not going very high, but you can get a little bit of a view of it there. Goes up, and then immediately comes down. It kind of still stinks like we have a short or something on the low side, doesn't it? Really, really does. And part of me thinks that maybe what I need to do, I'm just going to turn the power off here. Maybe what I need to do is try to figure out where the B plus feeds to the rest of the circuit and disconnect that. A lot of times there's a jumper link that does that. So I could lift a jumper link and then that 120 volt rail or whatever, you know, that we're looking at on there would be disconnected. That would help us identify that there is a short somewhere on here. And if we remove that jumper link and the voltage comes back, then we know that the short exists beyond that. Looks like it makes its way over to this section of the board. This is where a B plus is going to be used for like the flyback and stuff. Via this, probably like an inductor or a coil or something. It's hard to tell what it is, but there's something there that looks like that's connecting the positive side here, which is there. It ends up over on this side, there. And there's a jumper link there, to there, to there, to there. So it kind of makes its way over here. Probably this is going to be found on the flyback itself. There it is right there. Looks like it also makes its way over to this section of the board. Where was I? I just lost it. I think it was like a jumper link here. Probably is part of the feedback circuit or something, right in this section that feeds back through the optocoupler. There's an optocoupler right there, so that's the feedback circuit. So if I disconnect this link there and we still have it shorting or resetting, then I'm going to suspect that the feedback circuit has a problem or something. So let me lift this inductor out of the board and let's see what that changes exactly. Okay, so the B plus positive side goes to there, but now no longer makes its way over to the flyback. But it should still be making its way over to this feedback circuit. There, right there. So let's see what that does. We're going to change this to more than 2 volts per division. I'll change it to 50 volts per division. And I'm on the B plus cap here with the scope. So let's see what we get out of this now, if we're getting some kind of B plus or it keeps resetting. All right, here we go. 3, 2, 1. Ah, okay. You see that? We have B plus. It was 102 volts. Okay, so the multimeter's on DC volts. Let's check B plus now with the multimeter. Now remember, the monitor is off. Well, the power supply is off, so I'm going to turn it on. 96 volts. That seems kind of low, to be honest, but I have no idea if that is correct. And I just turned the TV off. And there we go, power supply. Yeah, so power supply works. Nothing is wrong on the high side. Now I fixed that cap. We have a short over here. And that's bad. And the reason why that's bad, the flyback could be shorted, the horizontal output transistor could be shorted, and if that's the case, this TV's junk. I'm not going to bother to fix that. I don't have a spare. I was hoping the other board would be the same, and I could just use the horizontal output transistor on there. But when that inductor is connected up, then yes, we have a short on the B plus rail over here in this section. In fact, what's interesting is if we turn this back on again, okay, I can hear the power supply start up, but the microcontroller, those parts should be powered up now. Let's look at the other voltages. There we go, 9 volts. Because that's what the microcontroller or whatever circuits run off of. There's probably like Zener diodes, brings it down to 5 volts to power those chips. But those are the 2 rails. Where was it? This one again, right here. Yeah, 9 volts. Yeah, like down here, 4.3. 9 volts over here, or like 8 point something. I mean, this could all be completely normal. Who knows? 4.7 over here. You know what? This is still progress, so this is good. What I need to do is I just turned this off. Usually, let's see here. Because the switch mode power supply actually works now, theoretically, it might discharge this cap. In fact, I'll just demonstrate that. Okay, we're at 26 volts. If we turn this on, there we go, 167. But because the switch mode power supply is running, it drains down that capacitor. Now it's self-recharging, but as long as it's under like 40 volts, it's fine. You're not really going to get a shock from 6 volts. But before the switch mode power supply wasn't working, remember it was like in that fault state, that's why this would sit at 160 volts just kind of indefinitely. You know, it would eventually self-discharge, but not quickly at least. It would take a long time. So now we have to figure out where exactly the short is over here. This whole section that uses B+, something is amiss. Now, there are a couple things we can do. I can measure the horizontal output transistor, which is this part right here, which I'll get a better view of in just a second. We can measure that, and we check it for diode check. It just has normal collector base emitter, so that's pretty easy for us to measure. I have the horizontal deflection unplugged right now, but what I was thinking of doing is, well, a couple things. First of all, I'm just going to plug this deflection yoke back in. So what I want to do is I want to show you, and I've drawn some red marks on the board. This is the path of the B+ from the power supply. And I'm in continuity mode, so this kind of makes its way over here and over here. This connector right here, these 2 pins, this is the deflection yoke, the horizontal. And we can see that the pin over here on the left is actually connected directly to B+, but this side actually has, it looks like 3 ohms or something like that, which I think is going through the flyback. So this pin I circled here is less than 1 ohm, so that's a direct connection. Anyways, what I really wanted to show is that if we go down here, this is the horizontal output transistor, and the collector is connected. Well, it's 0.7, but it's essentially connected to B+. I don't know through what, I'm not 100% sure. But this is not shorted. So if we switch this over to diode test mode, what we can do is, we can check that this is shorted, and it's not. So 0.4 looks good. That's collector to base. And this is 0.4 collector to emitter. That looks good. So there's not a problem with the horizontal output transistor, which is great, because that's a hard to replace part. It's still replaceable. But there's not a whole lot else on here at this point. And I think what I'd like to do is actually just feed voltage directly into the high voltage B plus section of, and I can do that by clipping onto a capacitor. There's a B plus capacitor that's after the component I lifted, so it's no longer connected to the whole power supply. This cap here, this side of it, the left side is the positive side for the B plus, and the right side of this cap, I'm touching the heatsink, which is ground. Yeah, so that's grounded. So I'm gonna throw caution to the wind, and I'm gonna use my bench power supply, and I'm going to feed some voltage into here, like say 20 volts, and let's see how much current this draws. This shouldn't really be doing anything right now because the driver and the oscillator is not running. So it's essentially off. It should be off because there is no horizontal drive coming from the microcontroller because it's not going to be powered up because I'm only powering up this stuff. But we feel there's some kind of an excessive current draw or short over here. So let's feed some voltage into here and just see what the current draw is. I mean, and theoretically, actually, I could use this other scrap board and we can kind of do the same thing. I know the board design is different, but it's similar enough. Oh, there's corrosion down here on this board. Interesting. It's similar enough that I think we can actually run that test. All right, sorry about the angle, but I have it at 12 volts. I have it at 1 amp. So it's going to put 12 watts into the circuit as soon as I turn it on. Here we go. Nothing. Wow. It's not what I expected, to be honest. Let's crank it up. 30 volts is the maximum on this power supply. And I'll just turn this down a little bit. We'll do 500 milliamps at 30 volts. Here we go. Aha, it's shorted. Well, that's interesting. So as soon as I turned it on, there it is. It's a dead short. Now the funny thing is, when we had it at 12 volts, it wasn't a dead short. Let's try that again. Oh, now it is. It wasn't a second ago, right? It was all zeros. So what I mean by dead short, if you're not super familiar with the way these work, it's going to supply 11 volts in this case, 500 milliamps. As soon as I turn this on, it's supplying 500 millivolts and the voltage is dropping down to 0.29 volts because this is in constant current mode. And now I have the leads unplugged. Now see, it's all zeros at the bottom row. If we plug these together, there it is. It's 500 milliamps and we're at 0.03 volts. And I think that's because, well, whatever's shorting it is not, I guess, not 100% dead short because the voltage was a little bit higher, but it's still quite the short. So the interesting thing is if I feed some current into this, like say I put it back to 12 volts, 1 amp, that should be 12 watts. And that means something should be getting hot. Whatever's shorted on here should be actually warming up. So maybe I should grab the thermal camera and we should look to see what's warming up. All right, so this is the Top Don thermal camera sent in by Top Don. TC004, thank you very much for that. The TC view, there it is. System is initializing. So this is connected up. I have it 12 volts. I'm gonna set it up to 1 amp again. So there we are, so 1 amp exactly, and that means 12 watts is gonna go into this. Something should warm up. So I can kind of try to see, I'm gonna look through this side of the board just to see if it's actually warming up or not, and then I might have to look at the other side. Here we go. Okay, dead short's happening. Well, nothing really looks like it's getting hot except for maybe the clip lead, because 1 amp is going through that thing. Okay, as you can see, I've put this back down. Let me turn the power supply back on. Okay, we got our dead short. Let's look for things getting warm. It's hard, of course, because these silver heat sinks reflect. Nothing's obvious with the current draw. I'm going to pull the neck board off, see if that changes anything. That changed nothing at all. Okay, next I'm going to unplug the deflection yoke. We're at like 0.2 volts right now, 1 amp going into this thing. Okay, deflection yoke's unplugged. That made no difference. I'll just unplug the vertical as well. That can't possibly make a difference, but I'll unplug it anyways. No, that changed nothing. So the short is still there. And I mean, I'm looking around with this and I just don't see anything getting warm. I'm putting 1 amp into the board. Something should be getting warm because there's a dead short. I just don't see it. I don't see it at all. So one of my concerns here is that the problem is the flyback. And the problem is the flyback is quite a large thing. Therefore, it can easily absorb quite a lot of current and it's not really gonna, physically warm up. I mean, it will eventually, there's a trace that's warming up on the board a little bit. Now, the problem is there's a lot of reflection. So let me try to tilt this away from me. Yeah, I'm going to say that there's a hot spot on the board there. This is warming up. And that does seem like it's coming from the flyback. I just don't know if that's like a smoking gun or not. Is the flyback warming up at all? I won't touch it, 'cause as soon as I touch it, yeah, you know what? The flyback is warming up. The flyback is freaking warming up. All right, I know this is terrible. I'm like recording the screen of this, but that's the flyback right there. See how it's warm? I think the short's in the flyback. That's wild. I wonder if this happened because they had the deflection yoke unplugged and maybe trying to run the TV like that for an extended period of time killed the flyback. There's another picture of the flyback. These are some capacitors. That's the PCB over on the right side. That flyback, it's warming up inside. To me, that feels like a smoking gun. Like there's something wrong and it is shorted. Incidentally, by the way, the parts board, the flyback has the exact same footprint. And the part number was similar enough that I'm thinking, let me just double check. Does it really have the same pins? No, not quite. Well, it's got the exact same footprint, but I could see some of the traces on this TV, the one I'm trying to fix. Like that pin is connected to something on this board, but it's not on this. That's just floating. And so is that one. But both of those are connected on here. But on this parts board, when it comes to B+, this is the B+. There's that same kind of inductor. The thing I lifted on that is that component. And I removed one of the capacitors that feeds this whole circuit. That's gone. That was the one I was clipped onto with this thing. So what I'm going to do is I'm going to lift that same component and we're going to feed the voltage into this and just see what that does. Because to be honest, I don't really know if what I was just doing with the bench power supply is actually a valid test or not. Right, so I lifted a jumper that feeds the B+ into the horizontal section, just like I did on this one. And I have the red clip lead hooked up there. Ground is on the heatsink, just like it was on the other one. Let's do the same test and feed, well, first I'll start with 1 amp and we'll see what that does. Okay, here we go. Okay, so we're currently drawing nothing. 0 milliamps. And I know it's hard to see, it's flickering, but I'm gonna raise the voltage up to 30. And I mean, it went up to 0.002 for a second and then went away. So yeah, we're just drawing nothing. There's nothing happening on this thing. And I just have it rehooked up to the problem board again, and let's give it the 12 volts. Yeah, it went back to a dead short. I don't know what to think here, other than I think it's the flyback. And I'm not sure what to do next, other than I guess I'll just remove the flyback from this board and see if the short disappears. What else is there to try? All right, as you can see, the flyback has been removed. It looks in perfect shape. Absolutely nothing wrong at all. The connections are still made to the B+. I'm going to turn on the power supply. No short. No freaking short at all. It just 0.00 current drop. I put it up to 30 volts, 0.00 milliamps. So I think that kind of tells us this flyback is dead. So at this point, this pretty much confirms my worst fears. These are kind of irreplaceable. It doesn't even matter. I mean, this thing is not even worth spending any money on to replace it. Like, I'm not going to spend 50 bucks or whatever it costs on a replacement, even if it existed on a set like this. These things are just not worth it. This is a parts set at best. What I do have is this flyback. I know if I take this off, it'll fit on the board. So let's just try it. I mean, what's it gonna do? Just blow up or something? If that's the case, oh well. So I'm just gonna swap this over and we'll see what happens. It'll be an experiment. There is the bad flyback. Well, I suspect bad flyback. On this board now is the one from the other monitor, the parts board. And it's all connected up to high voltage anode connection to the neck board. You gotta like swap a couple wires over there. And our first test is simply to feed the voltage into this. Okay, power supply. You know, it's hard to see, but it's 12 volts, 1 amp. Here we go. Nothing. Let's crank it up to 30. Oh no. Oh, interesting. So now we're having the same problem again. You gotta be kidding me. Look, it's doing it. So it's not the flyback. So this flyback here isn't bad. And, well, I don't even know. What? What could be causing this? What could be causing this? Something else on here is going short. And it's, I mean, unless this flyback's not compatible, I don't get it. Because I had this off the board, the short seemed to go away. With this back on, it was gone. But as I ramped up the voltage, it came back. Previously, I had the neck board off. I had the deflection yoke disconnected. So there shouldn't have been any short. I mean, I guess the one thing I didn't do was disconnect the high voltage anode connection. I mean, is that somehow possible that there's some short going through the CRT itself? No, I mean, that's not possible, right? No, that doesn't make any sense. I'm going to turn to, no, still shorted. Let's take the neck board off again. Okay. And I've just unplugged the deflection yoke as well, the horizontal side. Let's turn it on. No, dead short. Dead freaking short. This is so weird. This is so weird. I am completely at a loss. Okay, so I turned the power supply on. We got the dead short right now. I'm going to crank it up to, well, maximum current. 3 amps. Something's got to get warm. Something has got to get warm on here. Okay, you know what? Horizontal output transistor. Wow. Could it be that transistor? Wow, I'm really stumped by this whole thing. I'm going to turn it back on again. Yeah, it's 3.2 amps going into this thing right now. Okay, well, that's interesting. That means I swapped the flyback for no reason. And I guess the question is, if we look at the other parts board, is the horizontal output transistor on this parts board right there the same? I just had an interesting thought. Why don't I connect this up again and let's get it to go into that short condition. So, okay, it's totally shorting right now. And I'm going to do, well, I'm going to turn the power off and then I'm going to do a diode check on the horizontal output transistor, which we looked at before and it was fine. So power supply's off, dead short. Dead freaking short. You're kidding me. Totally shorted. But I checked it before and I swear I did it on camera and it was fine. So there's some internal failure that I guess as soon as some voltage goes into it, it breaks down and it becomes a dead short. And I guess I missed that with the thermal camera last time. Oh, okay. Well, I'm going to remove the one off this board. It looks like it's got the same footprint and swap it onto this board. Okay, here are the two parts. The one in my left hand is the one I took out of this bad TV. It says BUT11APX, and then the last line is PH lowercase m 0306C3. I think that's like a date code maybe. And the one off the parts board, this one in my right hand, it's a ST part BUL312FR, second line CCOWVVW, and March 531. So date code. So this one says BUT, the one I took out, and the one on the parts board says BUL. I don't know, but you know what? The footprint looks the same on the board, so I'm going to put it in, and I do need to swap back the flyback because I still don't trust that this one is a perfect fit for this, and I'd rather go back to the other one. It's pretty quick to swap it over. Okay, the original flyback, the one that has an X on it, is back in. I put the horizontal output transistor from the parts board in here. This is the one with the X on it that seems to have a problem. Bench power supply is connected again. Let's, I'm going to put this down to just 1 amp again. So it's on. There is no current draw right now with the bench power supply on. I'm going to raise it up to 30 volts and we're at 0. So all is good. Let's see if this has resumed working again. Let's just see if it's a dead short. No, I think it is now a functional transistor again. Yes, it is. Look at that. So it is now fine. It has come back to life temporarily because we know that's going to break if we try to put any kind of high voltage on it. Okay, so yeah, no current draw at all on here right now. So what's left to do? See if the set runs. But I do need to reinstate the connection that brings the B plus from the power supply back to the high voltage section again. So I'm just going to do that real quick, which just involves fixing this little inductor down here that I pulled out. Okay, well, theoretically, this should work now. Everything is reconnected. The ground lead from the CRT to the neckboard's in. Deflection yoke connections are both on. Degaussing coil not connected, nor is the speaker. High voltage anode is connected. Focus voltage and the grid or screen voltage are both connected up to the neckboard. I had to switch those over when I moved the flyback over. Power cord is in the wire management. Board is all the way in. Power cord into the power strip, which is currently turned off. We're actually going to turn the TV on just like this because I want you to be able to see the horizontal output transistor that I swapped in, because that could fail catastrophically and it'd be fun to catch that on camera. So here we go. I'm going to turn it on. 3, 2, 1. Okay. The TV just is doing nothing. It's on. I mean, the power supply should be running right now. We should have that B plus of almost 90 volts or whatever it is. And yet I'm going to reach over and turn this on. Here we go. 3, 2, 1. Uh-oh. There's definitely a burning smell coming from this set. Oh, yeah. Something is burning. I turned the power off. Okay, so what was really hot was that poor horizontal output transistor. Wasn't like it was burning hot. It's looked like it's at around 45 degrees. But that's not right for a set that's off and shouldn't have been getting hot. What else was getting hot? Stuff on the power supply. I'm not really seeing other stuff that is hot. So my assumption with the other one, when it went bad and went short, the transistor that is, that's why the flyback was looking warm, because it was sort of shunting the current through it. But it's funny that I could kind of smell like a burning smell while this set was running. But I'm going to do this again, and I can see that the board was very hot, right where that horizontal output transistor was. Let me just make sure I didn't short anything or do anything stupid. Okay, horizontal output transistor still looks normal, 0.45. Okay, I think what I'm going to do is just turn this on again, and let's see if anything gets hot on the backside. I'm going to look at the horizontal output transistor. Well, it doesn't look like it's overly hot right now. That's odd. So now the board's off. Huh. So one thing is, when I turned it on earlier, I tried to turn it on. I reached around and tried to push the power button. Didn't really do anything, but I wonder if that's when the horizontal output transistor started getting really hot. So I'm going to turn the power back on. Currently the transistor seems fine. And nothing seems overly hot on the back side of the board either. Let's turn that off. Yeah, I'm touching the heatsink that the hot is on, and it's not even warm. So my assumption is it got hot when I tried to turn the set on. So I'm going to turn this back on, and the power button is this one. Yeah, and it doesn't do anything. Oh, yep, and instantly horizontal output transistor got hot. There are more faults with this board. I cannot believe it's off right now. By the way, it's the power's off to the whole board. I cannot believe how messed up this whole thing is. So yes, as soon as I tried to turn the set on, the heatsink that the horizontal output transistor's on, it got really hot. So my hypothesis right now is that the base drive on this transistor is not getting the normal 15 kilohertz it should to start up the entire set. Therefore, what's happening is it's just causing it to conduct all the time, so it basically creates a short and overheats that part, which almost certainly would have killed the other one that's in here. So that's why it was failed. Now the question is, why do we have no base drive, and like, why is it just outputting a stuck signal? Usually there's a little transformer that drives the base, and typically a smaller transistor does it, or maybe it comes right out of one of the ICs, and it's probably this one since that's proximity to all of this stuff. So ultimately, the task at hand now will be to kind of reverse engineer and go backwards to figure out where the base drive for that transistor goes to, so that I can try to identify what's going wrong. Now, unfortunately, I know this video is getting long, so I'm gonna have to end it here. I'm sorry about my troubleshooting, it hasn't been the best, but I'm not super familiar with fixing these TVs. I mean, I know these all operate in a very similar fashion, but I feel I've done some decent work. I'm sorry, I falsely accused the flyback of being bad. I just didn't see, well, I just didn't expect the original horizontal output to be good and then go bad when you give it a voltage, like it breaks down or something and then comes all short. And then it goes back to being okay when you test with the multimeter. Those are difficult ones to fix, and it's not something I've ever run into. I have a feeling people watching this, if you're a TV repair person, you probably ran into that, but that's not something I've ever run into. And that's what led me to believe that the original flyback was bad, which is what I put back on the board. I don't think this flyback is bad. I really, really think this is a drive problem for the horizontal output transistor. That's my hunch, that's my hypothesis. I think it was a red herring that the flyback was bad. So yeah, original one's back in. And yes, so it'll be in the next part when I try to figure out how to fix the drive circuit, if that's even possible with these highly integrated sets. Sometimes it's just not. So if you like this video, thumbs up. If you didn't, you know what to do. Huge thanks to my supporters. Subscribe, all the usual YouTube junk. And well, that's going to be that. So stay healthy, stay safe, and I'll see you next time. Bye.